Hi, good morning, students. In this class, we are going to see deformers. See here, we can find the menu deform, right? We are going to see the use of the lattice deformer and a few of the nonlinear deformers. So basically, these deformers are used to transform the shape of an object when it is applied. Okay, say for example, if I'm having a polygon sphere, if I'm having a polygon cube or a polycylinder, then if I want to bend the cylinder, then by modeling, usually what we used to do, we used to select the vertices or edges, then we may do it manually, or we can do it with the help of curve. Okay, so but these deformers help us to do or to achieve all those transformations over the polygon mesh, okay, without much what detailed work using vertices or edit points or edges or faces. Okay, so these deformers basically help us to transform any object from the current position or current shape into some defined shape, some other shape. If it is a bend, it is going to bend. Okay, so these kind of deformers, these are going to help us in rigging a car, cartoonic way. Okay, when we are going to rig a car, it is a mechanical rigging. In that mechanical rigging, uh, when we want to make it some cartoonic transformations, when we want to apply some cartoonic transformations for that car, okay, mechanical rigging we can do using the values of set driven key and all these things, okay, by constraints and controller curves anyways. But these transform shapes help us to create cartoonic rig, okay, for any object. Okay, say for example, if I want to stretch and squash a car, just imagine a car is a cartoonic car, cartoon car. Okay, it is a funny car, so I want to give it a stretch and squash feeling, so I can use the squash deformer. Okay, I can apply the squash deformer. If you want to twist, means if I want to completely twist the car from end to end, okay, make it to feel like a twisted towel, then I can use this twist deformer. Okay, so before starting to rig our car, we need to learn about a few deformers like the usage of lattice deformer and the nonlinear deformers like squash and twist. And there is one more thing called expression editor. Okay, in Windows menu, right, in animation editor, you can see something called expression editor. Okay, in this expression editor, we are going to write a small code. Okay, coding in the sense it is not a tough coding, it is a very small simple code. Okay, which will help us to understand how the rotation of the wheels of the car and all these things can happen. Okay, so before that, I just wanted to make clear all of you have had some knowledge about these deformers when you are learning your modeling, right? So we will start with lattice deformer. Okay, we will do some small examples. I'll make a small example. This session is all about understanding how we are going to apply or implement this two or three deformers into a bigger rig, okay, because when we are rigging a bigger mechanical element like car or something, we need we would have already given many inputs like connectivities, expressions and everything. Over that, how we are going to apply these deformers? Okay, so for that we will see few examples. You just practice these two examples. Okay, the next session we will start to dissect the car and to how to naming and everything. We will start with the complete mechanical rigging of the vehicle. Now we will go to start practicing this basic deformers like lattice and nonlinear deformers, right? So say for example, I'm just going to take a polysphere. This polysphere, I'm going to consider it as a ball. Okay, just imagine I'm going to rig a ball. Okay, a small ball. Right, there are too many methods to rig any object, like we can use bones and joints and constraints, or else we can use deformers. Okay, or else we can use connection editors and expression editors. Okay, so in this method now we are going to use deformers. Okay, if you want to give stretch and squash, I can use the squash deformer. Okay, so if I want to twist the ball, I can use the twist deformer. Okay, and there is a lattice deformer which I can also apply to give stretch and squash for the separate parts like top and the bottom. Okay, so in this example we are going to use only deformers. Okay, so the complete ball rig may be achieved with different combinations. Okay, but we are going to just simply apply only deformers. Okay, so just taking a ball. Okay, I have given scale size as 5 and I have made the translate y into the ground position, and so before that I'm going to modify and give freeze transformation, and it is simple. I'm going to give the name ball, ball. That's all. Right, now what am I going to do? Actually I want to differentiate between the upper half and the lower half of the ball. So for that I'm going to click and apply some material so that it will be distinctively clear. So I'm just going to give some material. I'm giving Lambert. Okay, and Lambert, I'm going to change the color of the ball into something like this. Okay, or I can not feeling good with this color. Okay, this color is okay. So I want to differentiate between the first half and the second half of the ball. So I'm just going to take the select the faces. This face, okay. Oh, the symmetry is on, so it is getting selected opposite sides. So I'm going to the selection tool, symmetry settings, turn off the symmetry. Okay. Okay, now I'm going to select one symmetry, sorry, one face, and I'm going to select the other side of the face and double click. And yes, one face and the shift select the other side of the face, double click on it. Okay, and I'm going to apply another material to differentiate. Yes, the color by default it is white. Let me make it more white. Okay, I think this is okay. This is clear. Now you can see it is a ball, but still I think it is not a complete half. See, this is the middle line, but I have taken the upper half. But no problem. Okay, this is just for a reference. This is not a some complete perfect ball rig. Okay, we are going to practice the deformers in this. So after creating this, now I'm going to apply a lattice deformer. Okay, Coming to the front view, see lattice deformer, it is like we can transform the shapes of any part of the mesh but not selecting exactly the vertices. Okay, because you just see we have too many number of edges and too many number of vertices here. So if I want to make a change in this area, if I want to select this entire area, either I need to do soft selection or I need to do select each and every vertex manually. Okay, instead of that, I can apply a lattice cube which will control a specific area when the vertex pointers of the lattice is selected. See, I will tell clearly how to apply lattice. Go to vertex mode. I'm going to select this first half of this polysphere. Okay, make sure not any other vertices of the other side of the body is got selected. Okay, I'm coming to front view. I'm going to deform, and here you can see the lattice deformer, right? Okay, just keep everything in default settings, reset everything, and just going to create lattice deformer. Okay, see, now you can see a container has been created. Okay, you can select this is the lattice container and this is the lattice base. Okay, actually this is the container and this is the influencing part, FFD lattice. This is the container and this is the influencing part, but both should be there one after another. Only then the lattice deformer will take effective transformation. Okay, now I'm just going to select any one of this, like it is not the base, it is the lattice container, sorry, lattice effector. I'm going to increase the subdivisions T, U and everything. Okay, so I'm going to make everything as some 5. Yes, okay, now I'm just going to front view, change into lattice points. Now see, if I'm selecting this lattice points, you can see this part is getting transformed. Okay, so for stretch and squash of a ball, I can apply the squash deformer, but it will take effect for the full ball. Now I want to get control over only the top part. Okay, so that I can select my own set of lattice points where I just wanted the controllers to control. Okay, so this kind of action the lattice deformer will help us to take. And see, I can increase it more, like I'm just going to make it 8 by 8. Okay, so I'm coming to the front view. I'm going to the 4 wireframe mode. I'm going to lattice points and I'm going to select this area. Okay, let's see, it is a cube, complete cube. Okay, so then I should select all these areas also. So better we need to select everything. Like I'm coming to the front view. I'm going to select this entire area of the ball. Okay, just this is for what kind of reference. Okay, and I think I can select this part also. Let us see what happens. See, this area is not transforming properly. Okay, so let me select all these areas. Okay, okay, some kind of transformation is here, right? Okay, now how am I going to get control over this lattice points? Because every time I cannot select each and every lattice points and do stretch and squash for these objects, right? So what can I do? I'm just going to create a cluster. I hope you remember we have created cluster for spline IK for the backbone of the human. Okay, the same cluster we are going to create here, but with a different option. See, there we created using cluster curve in the select menu, but here we are going to use cluster from the deform menu. Okay, so for this lattice points, to control these lattice points, to get this kind of stretch effect, I'm going to create cluster from the deform menu. And when you are creating the cluster, by default it will be having the option relative turned off. Okay, but you should turn it on. Don't forget to turn on the option relative, then click create. Now see, I'm going to create an empty layer. I'm going to give the layer the name uh, top lattice, and I'm going to select the lattice base and the lattice effector, and I'm going to add it to the selected layer. I'm going to turn it off. Now I can see cluster 1 handle is there. So this cluster 1 handle acts as the influencer for the lattice. Okay, so I'm going to name this cluster handle as top cluster. Top cluster. So the same way I'm going to create one more set of lattice for the bottom cluster. Okay, so I'm going to, again, what I'm going to do, go to vertex mode, I'm going to deform, create lattice. Before that, select the vertices, right, and go to lattice, create it. Then I'm going to change it to my convenient. Okay, then again, what I should do into lattice points. Then I'm going to select the lattice points like last thing, like for the top how I did. So I'm going to select it. So okay, I feel this is okay for me. Okay, right. So I'm just coming to the front view. Now again, I'm going to create one more cluster to control this lattice. Okay, so for that, go to cluster, transform, and create. Sorry, yeah. Where is that? Yes, deform, and go to cluster, create cluster. Yes. Okay, now again, going to create one more empty layer. Name it as, what happened? Okay, I have given a name for this, but it did not happen. Top layer, top cluster, sorry, top lattice. The name is invalid. Okay, okay, I should not give the space. Yes, top lattice. Now I'm going to create it, and I'm going to give bottom lattice, bottom lattice. So again, I'm going to add this bottom lattice and base here, and I'm going to hide this because hereafter we don't need the help of these lattice points. Okay, now we are going to create controller curves and connectivity for the clusters. Then after that, we are going to apply the non-linear deformers. Okay, this is a general deformer. Then the next part is non-linear deformers. So after adding different layers, now I'm going to give this cluster again a proper name. It is a bottom cluster, bottom cluster, bottom cluster. Now yes, okay. See, actually it is not a center. Okay, you can see here I should have added one more edge so that I can have proper exact center or middle. But anyways, this is for a practice. Okay, so next thing is I'm going to create a controller curve. uh, you know how to create controller curves. Create controller curves on controller curve. I'm going to create it in the bottom, take it to make it or keep it there itself, give the name bottom control, go to edit, delete by type history, then modify freeze transform, duplicate it by control D, bringing it to the top. Okay, now give the name top control, then again delete by type history and give modify freeze transform. Okay, now we are going to give connectivity to the clusters. Okay, so the top control and the where is the cluster? Top cluster. Okay, let us keep the similar objects together so that it won't be confused. Okay, top cluster, bottom cluster. Okay, bottom control, top control. I'm just going to keep it together. Okay, bottom control. So top control and top cluster. So how to give connectivity? Yes, top control. Shift or control select the top cluster. Okay, I'm going to give go to the modeling tab. Sorry, yes, change it into rigging. In the rigging tab, go to constraint. Okay, just take the point constraint, select the maintain offset, keep the maintain offset selected and give yes burst. But first we need to confirm, we need to select the controller curve, control select the top cluster. I'm just going to give add. Okay, the point constraint. Same thing like we're going to give it for the bottom controller curve, bottom cluster, go to constraints and point constraint, just give add. Okay, that's it. It is very simple. Okay, this is how we are going to apply the lattice deformers over some pre-built mechanical rig. Okay, we are going to apply these deformers over another rig. Just keep in mind it is not over the mesh. Okay, we are going to apply this deformers and we are going to achieve some other shapes, okay, on top of a rigged model. Okay, so for that this is the base. This is how we are going to use it. We are not going to touch any of the joints or bones or paint weight or influence anything. So just we are going to do this. Okay, so just think about the mechanical rigging there. We don't need paint weight tool. Okay, uh, but anyways we can use joints and we can use the stretch like what we did for fingers and all these things. Okay, but even then we can apply these deformers and achieve some other shapes, some different shapes. Now we can see how we can apply another deformer in the same object. Okay, see this mesh is already having how many inputs or controls? One is the lattice deformer, then the lattice is connected to the cluster, then the cluster is connected to the what? Animation controller or controller curve. So again for the same, mesh, we are going to give two more inputs, like two or three more inputs. Okay, the first input I can try is by going to the deform menu, and I'm going to the non-linear deformers. Okay, we saw lattice deformer. This time I'm going to see the non-linear deformer, and I'm going to select this, go to non-linear deformer, and I'm going to give the option squash, make everything by default, and give the option create squash. Okay, see, you can see a curve appeared here. Okay, that is actually the squash handle. You can see in the outliner the squash handle, right? It appears from the top. This is the high bound and this is the low bound, or at sometimes maybe this is the high bound and this is the low bound, right? So that doesn't make most changes. Like we can have the low bound and high bound difference anywhere by selecting here. Okay, I'm gonna keep it here. This thing I can keep it here. Okay, you can see the high bound and low bound, which controls the influence of how the this particular nonlinear deformers starting and ending effects are applied, right? So see, I'm just going to, this is select the factor. Actually this factor is going to show us the influence. See, I have selected the sphere or the ball, I have applied the non-linear squash deformer. Now I'm going to the inputs and I'm selecting the squash, select the factor. Now I'm going to click my middle mouse button, increase or decrease the value. You can see the squash deformer has been applied. Okay, but see, it is going as endless, so we need to limit this. Okay, and also we cannot animate using this attribute. Every time we cannot select this attribute and every time we cannot give key. Okay, this is not going to work. So we are going to attach it with a controller curve, and for that controller curve we are going to limit the translate y position. Okay, that you know very well, I think so. Okay, so before that we'll see what is this low bound and high bound. See, this low bound, it is a -1 and high bound value is +1. I'm going to make the low bound 0. Now I'm going to check this factor. You can see, okay, the lower part of the what the mesh is not working or not taking effect, because you can see this is the lower bound limit, which after giving 0 it has came to the 0th position. So even for high bound the 0th position is this. Okay, so now I'm going to give low bound -1, -1. The low bound went to its position. I mean it will take the position of the selected object. Okay, though, so actually the pivot point or the center point of any nonlinear deformer relies on the center point of the selected or the applied object. Okay, so for this deformer, this is the center point or the 0th position. Okay, and the top point of this particular mesh is the high bound, and the the lower part of this particular mesh is the low bound. Now see what happens when we click on the factor. You can see only the lower part works because the higher bound I have given 0. Okay, so just to make it even, I'm going to make it 1. And the factor, when we select, you can see it is very sensitive. See, in some computers, in some Maya settings, even if you move, click on middle mouse button and move a little bit, okay, it will go like this and this. It is uncontrollably, it may go. Okay, so to control that thing, we can increase or reduce the decrease the influence by selecting this envelope. This envelope is the influence. Okay, see, for say for example, I'm just selecting the factor. I'm going to see it has been enormously expanded. I'm going to control Z. I'm going to give the envelope 1. It is there, right? I'm going to envelope 0.5. Now I'm going to click select the factor. See, I think the the stretch and squash effect is not very sharp. It is very smooth. See, because previously when it is 1, when I squeeze it, it can go sharp, too sharp, or stretch, it can go too stretch. Now I'm going to reduce the envelope too low, like 0.2. I can see the factor. Still it is going, but it is in my control. Okay, previously when I just simply click the mouse itself, it will run far. So I can give 0.1. Okay, now I can select, see, yes, okay, that's all. This is the maximum position it can go. So but no problem, keep it into default position, right? Then actually we may get confused because we need one more controller around this ball. We are having top controller, bottom controller, and we need one body controller. Okay, but this deformer is confusing us in the shape of curve to act like a body controller. Okay, so before that we will finish connectivity for this deformer, then we will create body controller, and then we will see the connectivity. Okay, so to create a controller and give connectivity, we're just going to the front view. I'm just going to connect this non-linear squash deformer into with sorry connect this non-linear squash deformer with controller curve. I'm going to create a controller curve. Okay, so the stretch and squash is pulling up and down, up and down. So I'm going to create a controller curve in the shape of an arrow which is pointing up and down, a two-sided arrow. Okay, just going to create it. Sorry, yes. I'm just clicking hold of X, and the screen capture software is showing too many X's. Yes, okay, so I can resize it, select it, and I'm going to give modify center pivot. Now I'm going to resize it. Okay, and I think I can edit the vertices also. I can bring it to the top, bring it to the bottom. I hope the shape is good. Okay, I'm just going to keep it here, and I'm going to reduce the size a little bit more. I'm going to keep it to the top. Before that, I need to finalize up to which position I should pull up my top. Okay, so this is my maximum position. I can stretch my ball. Okay, I think so. I can keep it here, and I'm going to keep this here. Okay, so for this I can set my translate y limit for my upper. Okay, for my upper stretch, but let us see that there is a very simple part which you can do it. I'm going to see, I can make it a little bit lower also, no problem. So go to animation, key, and take the set driven key. And before that, I'm going to give proper name for this, stretch and squash control. I'm going to give modify freeze transform, and before that edit delete by type history. Okay, now it is well good and fine to get the inputs. So I'm going to open the set driven key here. So this is the driver, load as driver, and translate y. Okay, we are going to use it, translate y. Translate y. All the other things we don't need. Okay, so just right click and lock and hide selected. Okay, lock and hide selected. But anyway, that thing we will do in the last step. Okay, now I'm just going to keep it as it is, no confusions. So keep it, translate y, and which one is going to act as the driven is this non-linear deformer. Okay, so this non-linear deformer, if I make it to load as driven, you can see the attributes of this general nonlinear squash handle. Okay, this is the handle. Okay, in the sense I can move the entire influence out of the body of this mesh. So this is just an handle. When you select it and load it, it won't take any effect. Okay, you cannot see this influences and everything. So for that I'm going to select it, come here to this inputs, and select the factor and give load as driven. Okay, now you can see squash 1 and squash handle 1. Here you can see the squash 1, you can see the factor here. Okay, so by default everything is 0. Okay, the translate y of this one is 0, and the factor value is 0. So okay, so I'm just going to give key, and I'm going to move it to the top, translate y some 2 or 3 4. Okay, now I'm going to select the squash handle. I'm going to increase the value of the factor into 2. Okay, 2 is too much, I think so. Then I'm going to give 1.5. Okay, or I'm just going to give 1 or 0.75 or 0.5. I think this is enough for a ball to stretch. Okay, or 0.3. Oh, what happened? Oh, okay, my Maya has got crashed. Okay, okay. I'll restart it. I'm sorry guys for that crash of the software. So actually I could not recover the file. Okay, so again I did up to this. Okay, now I think I have stopped by the place of giving set-driven key connections. So I think you can go for that. So I'm going to take the set-driven key again. Okay, go to set. Okay, so I'm just going to load this as driver and translate y and select the squash handle and okay, make it as driven. Now you can see the squash one and you can see the factor. Okay, so the factor value, it is 0, and the translate y of this value is 0, so I'm going to make it p. So again I'm going to increase the translate y of this up to somewhere here, some 3 or 4, and now I'm going to select this and go to factor value. Select the factor value. I'm going to increase the factor, sorry, increase the factor value up to this, so 0.91. okay, it is okay, or 0.9 is okay. So actually this is the place where we got the software got crashed. So right, I'm just going to make it 0.9. I'm just going to key it. So again I'm going to make it 0. So I'm going to bring it down, so -5 or -3, this, or -4, and I'm going to select this factor value. I'm going to make it flat, like 0.5, sorry, -0.5. Okay, so for that this value should be in the top a little bit. Yes, -3 I can keep. Now I'm going to change it 0.7, sorry, -0.7. Okay, stretch and squash. Yes, the factor value is -0.7, and the translate y value is -3, and I'm going to give key again. That's all. Now just going to give stretch and squash. It is working fine. Okay, so before that it is fine. Yes, it is fine now. The thing is, I need to set the limit for this control. Okay, see, after finishing the stretch, still this controller curve is moving. So what is the maximum positive or the plus y position I have given us? Translate y is 3 I have given. Yes, 3 I think so. So I should limit the information of translate y towards the up of this control into 3. So I'm going to make attribute edit, going to attribute editor, and here, you know very well, select the stretch and squash and go to the translate. So here in limit information for the translate y of this control, okay, I'm just going to pull it to the top, and I'm going to see it is like actually 3 we have given. Okay, so 3 I'm going to give it to the maximum value. Okay, and when I'm pulling it down, I have given the value -3. Okay, so -3, I'm just going to push this side. I'm going to give the minimum value. Okay, so now, so I should save each and every step of the file so that I can recover. If you too can follow this. Okay, yes, right, it is fine. It is -3.32 it is showing. Okay, no, it should be -3. Actually we stopped it in -3. Okay, so I should pull -3 here. Okay, that's all. So it is fine, it is perfect. Okay, so I'm going to make it 0, and let us create one more layer. Already some layer is there. I don't know what for it. Yeah, it is a blank layer. This layer, I'm going to add this squash deformer so that it won't be confusing us when we are creating a body control. Okay, so this is squash deform. Squash deform. Select this object and add the select object. Yes, you can turn it off. Now okay, I'm going to create a body control. Okay, close this driven key, create a body control, controller curve, create a body control. Yes, I'm going to create a body control. Yes, it is done, and I'm going to make it I'm going to give proper name for this. It is body control, and give freeze transform, and I'm going to, okay, but how to attach this body control with this object, right? We need an intermediate element or an object or a node, actually, to mention technically, it is a node which can act as a connecting agent between the body controller curve and the mesh. Okay, so for that I'm going to create a joint. Okay, so I'm going to the rigging tab. I'm going to create a joint, take the joint tool. Okay, reset it by default. Okay, I'm just going to wireframe mode, click on middle of the object, just simply click only once, one click, and give enter. Okay, I think I can reposition this controller curve. Yes. Okay, right. Modify free transform. Okay, now you see this single joint. Okay, make it as a root joint, give the name as a root joint. Now this root joint is going to act as the intermediate to help us in controlling the skin. See, keep in mind, we are not going to give bind skin and all these things. Uh, Sorry, we are going to give bind skin, but we are not going to do paint weight and all these things. Okay, so simply we are going to give bind skin, that's it. So no paint weight and all these things, because we are not using that technique, we are using deform technique. So just select this bone, shift selected this mesh, and go to skin and give bind skin. Okay, keep it by default, give bind skin. Now this joint we are going to connect with this controller curve. Okay, so we are going to give constraint for this joint, body control, and select shift select this root joint and go to constraint, give point constraint. It is only to translate. Okay, so I'm going to give only point constraint, right? So now I can see it is getting moved. Okay, so but what is the problem here? All these controllers clusters are in different layers. Okay, so for that we need to create one more master controller, and we need to bring everything inside. Okay, and also before that we need to limit the information of this controller. Okay, so that it won't go to infinite. So I'm going to attribute editor. You can see the limit information. Sorry, yes, the limit information, the translate y. I can take it to the top up to this much. Okay, so the maximum position I'm pulling it, right, and again I'm making it 0, I'm pulling it here. Okay, so this is the maximum position it can translate, and the same thing I'm going to give for this controller also. So I'm going to pull it to the bottom after this much. I'm going to the, sorry, oh, hopefully I'm not going to get some error again. I'm saving it for the safe, saving it. Yes, I'm going to make it 0. Oh, what happened? Yeah, yes, actually I should pull it to this side. Okay, and give the tick mark, the minimum value, because it is in the minus. So I'm going to make it 0, and this thing I'm going to pull it to this side and making it max. Yes, yes, it is fine. So the problem what happened is, first, since it is the top in the positive side, okay, positive value, I have given this maximum. When it came, when it was in this case, first I have did a mistake by giving the different value. Okay, first I should have given the minimum value, not the maximum value. Okay, so now, yes, it is fine. Okay, and now I'm going to create a master controller so that we can bring everything inside and we can maintain the hierarchy and all these things. So I'm going to, where is it, curves. I'm going to create a curve. Okay, make it big enough, right? Go to the layers, and before that I think I can change the shape of the curve by selecting the alternate curves. I can give a little bit of different shape, differentiate among the other curves. Okay, because the body curves, there is a design language we need to follow. Okay, the body curves are all in circle, and the stretch and squash curve is in arrow shape. So the master control should be in a different shape. Okay, so I'm going to give a different shape for this master control. Okay, it is fine. Right, I'm going to make this a little bit bigger. Yes, I'm going to give the proper naming, master control. Now go to edit and delete the history, modify and give freeze transformation. Okay, now under this master control, what are the things that should be there? What are all the things in the, what are all the objects should be there in the master control? Okay, so under master control, see, under body control, we need to bring the top and the bottom control. Okay, so first top control and bottom control, shift select, click middle mouse button, drag it and put it under body control. Now what else is should come under the body control? The bottom cluster and the top cluster. Okay, put it under the body control. Then put the body control, the stretch and squash control also should come under the body control. Okay, now let's see, when I select the body control, it should move like this. Yes, then yes, top control, bottom control, stretch and squash control, top cluster, bottom cluster. Okay, so the put this body control under the root joint, sorry, master control, the master control. Okay, master control, body control, right? And when I move, it should move like this, and it is working fine. And when you select this cluster, it is working fine. Okay, this bottom and top control. Okay, so no need to bring the root joint inside, or sorry, root joint or the lattice inside the master control, because these are connected or constrained. Okay, given constrained with the different connectivity. Okay, because see, the top lattice points are connected or controlled by this top cluster, and which is controlled or connected with the top control. Similarly, bottom clusters are controlling this bottom lattices. So, and it is connected with the bottom control. So let all this other things, influencing things, be outside. Okay, the squash handle and everything. Okay, so it will work fine, and I hope it is working fine. Okay, see, I'm moving it from the position, different position, moving it in a different position. Let us check. Still errors may come. We need to move it to a little bit far position, and I am checking. Okay, stretch and squash is working fine, and this stretch and squash is working fine. uh, yes, the body control is working fine. Okay, so and I hope you understood very well. Okay, this thing, so just give a practice with this two deformers. Then see, we will see the next another important topic, like how to, which helps us to rotate the wheels and transformation and everything. Okay, so which is called as expression editor. We will see that now. So I'm going to take a new scene. Yes, so in this expression editor, uh, how one object's attribute is controlling the other object's attribute. Okay, this is somewhat similar to like what we saw in set driven key, but we are not going to give key or set keys. We are going to give little bit of small sentence of coding. Okay, it is not a big programming or something. Okay, just a simple sentence of coding. Okay, so I'm just going to show you an example. I'm going to polygon disk. What is this polygon disk? I never used it. Yes, I'm not comfortable with it, so let me take a poly cylinder. Okay, let me take a poly cylinder. Yeah, sorry. Poly cylinder. I'm going to make a gear wheel. Okay, I'm going to make a gear wheel. So let us see how it works. Okay, come to the poly cylinder caps here. I think no need to create caps. Okay, I'm just going to make a okay, so I'm just going to select the different faces. Okay, select the alternate faces, go to the face mode and select alternate faces, shift select the alternate faces, shift select the alternate faces, and I'm going to extrude. Okay, control E for extrude. Okay, so I'm going to extrude it. Okay, so I hope this may look like a gear wheel. This is just a representation. Okay, so I'm going to come to the front view, rotate it to 90 degrees. Okay, bring it to the top. Okay, I'm going to keep it here. I'm going to give the name of wheel 1. Okay, so I'm going to modify the, delete the history, modify the freeze transformations. Okay, I'm going to make a duplicate of this. Control D, wheel 2, and I'm going to move it and pull it and keep it here. Okay, I'm going to change the background color, Alt B. Okay, now it is clearly visible. See, after moving it, you can see the teeth of both the wheels are colliding. So by logic, if this wheel is moving or rotating, it should pull or push. This wheel should rotate in this way if this wheel is rotating in this way. So which is the same kind or a little bit similar kind of thing, which we are going to use it for our wheels for the rigging of a mechanical or vehicle, something like that. Okay, or any mechanical gear wheel or an engine kind of thing. Okay, so let us see how it works. So for this duplicate object, again I'm going to delete the history and freeze the transform. So for this object wheel 1, okay, wheel 2 should rotate. So I'm going to take select this wheel 2. Okay, so I'm going to Windows, animation editor, expression editor. In here it is showing wheel 2 is selected, right? So actually what I want to know, what I want to do now, I want to perform rotation. Okay, this wheel, if it rotates this way, rotate Z in plus value, and this rotate Z should rotate like this in opposite value in rotate minus. Okay, so rotate Z. Okay, wheel 1 dot rotate Z should control wheel 2 of the rotate Z. Sorry, rotate Z of wheel 2. Okay, so I'm selecting wheel 1 here. Okay, so rotate Z. Okay, select this, rotate Z. So it is showing wheel 1 dot rotate Z. Copy it, Control C, paste into the expression editor. Wheel 1 dot rotate Z equal to what? Again I'm pasting the same. Wheel 1 dot rotate Z. No, it is wheel 2, because this is wheel 1, wheel 2. Okay, wheel 1 rotation should be applied to wheel 2. Okay, so I'm just creating, oh sorry, I did not save it. So again I'm going to create it, rotate Z, wheel 1 dot rotate Z, Control C, paste it, Control V, and I'm going to do it wheel 2 dot rotate Z. Okay, I'm going to create. You can see the influence or the code which is in the wheel 1. Okay, so let us check wheel 1 dot rotate Z. Okay, wheel 1 dot rotate Z is being locked because it is getting influenced. Okay, so from wheel 2 dot rotate Z. So just keep in mind which one you want to influence, which object. Okay, which object should influence. There is two things. I thought this option, this object, I wanted this object should influence this object. So I have written code in this object, but that code has locked this object and was waiting for influence from this object, right? So by logic, when wheel 1 should rotate wheel 2, then wheel 2 should have the coding. Okay, so no problem, we will change the coding, but this is also logically working, but we need exact what code which should be present on the influenced object. Okay, so but see, this is working fine. So but what I'm going to do, I need to select and delete that expression, but I cannot find it here. Translate Y, even if I select rotate Z, I cannot find it. See, it is here, but in general you cannot find it. To find the expression, there is an option. See, you know very well it is written in rotate Z, so I'm selecting here. But if you don't know where the expression is, there is an option to find, like go to select filter. Okay, give by express, select by expression name. When you select it, you can see all the expressions written in the Maya scene. From there you can select any expression you want. Okay, so now I don't want this expression. Okay, so for I'm just going to select this expression and I'm going to delete it. Again I'm going to select by filter, come by object's name, select this object wheel 2. Okay, or wheel 2 dot rotate Z, right? Control C and Control V, equal to wheel 1 dot rotate Z, create the expression. Now when I rotate the wheel 1, yes, wheel 2 is rotating. Similar thing we are going to use in our mechanical vehicle rigging, right? And one more thing you can see here, actually how I wanted this wheel to work is in the opposite direction. See, both are rotating in the same direction, so that you can see in my mouse pointer both the gear wheels, okay, edges are getting overlapped, okay, but it should not be like that, okay. So when I rotate it this side, this wheel should rotate inwards, okay. So I'm just going to, how can I make this? Okay, so I'm going to again expression 1. You can change the name also properly here. This is rotation of wheel 2, right? Yes. Anyway, we'll give the name wheel 2. Wheel 2 rotate. Wheel 2 rotate. And how can I convert the rotation into minus value? This is plus value. This is also rotating in plus value. Actually, in this view it is in minus value, okay. So I should give the opposite value. This is plus or minus, no problem here. That is not the problem. In which axis it is rotating, it should rotate in the opposite, but it is rotating in the same axis. So I'm going to make it to rotate in the same, not in the same, in a different opposite axis by adding one more object, like one more small thing, like wheel 1 dot rotate into -1, okay. And just give reload. Sorry, it is the, yes, once again into -1 and just give edit. Now let us check if it is working or not. Yes, the minus value. So it is like plus value is, this will inherit exactly what or how it is working. But when I give minus value, it will work in the opposite direction, okay. So you can see it is working fine, right? So this is one small example of an expression editor. And one more thing, we are going to have multiple number of codes, and even in one set of code we can have multiple inputs. But actually the syntax of any code should end with a semicolon, okay. This may not be a problem now, but it may be a problem in future while editing or adding more inputs, okay. So select this code and give a semicolon and give edit. Now the thing is, I want you all to practice, like, just keep in mind, I'm selecting this and I'm going to rotate this, rotate Z, okay, right. So just imagine I'm going to duplicate this and I'm going to keep it here again, okay. Wheel 3 again, delete the history, modify freeze transform, okay. Now I want this wheel 3 should be influenced by this wheel. It is like, if I rotate this, sorry, if I rotate this, this is rotating. When this is rotating, this influence should applied here and this should also rotate, okay. How can we do that? The logic is simple, okay. We are going to give again inputs with the coding, like go to select by filter, create by objects, select by objects. So this thing has got some inputs and this thing is going to get the input now. So I'm going to take the wheel 3 dot rotate Z, copy it and paste it here, equals to wheel 2 dot rotate Z, okay. keep in mind wheel 2 rotation is already being controlled by wheel 1. Okay, so wheel 2 will automatically rotate. You need not to rotate the wheel 2. It will rotate automatically. When it rotates automatically by influenced by this wheel 1, that rotation of this wheel should influence this wheel. Okay, right? And last time we faced the thing like when we rotated this wheel also rotated in the same direction. Okay, but what will happen here, we will see. What is the code? Wheel 3, actually where is the code? Wheel 1 dot ohm. Sorry, I think I did not save the code, or I will see rotate z. Yes, the code is not there. Okay, wheel 3 dot rotate z equals to wheel 3 wheel 2 dot rotate z. Okay, create. Okay, now let me show you what happens. This is going to rotate, that is influencing the rotation of this wheel. So this is also going to rotate, and this will influence the rotation of this wheel. Okay, so let us check. Sorry, yeah, here. Okay, this rotation is happening, but again, what is the problem? See, again, what is the problem here? This rotation is perfect. Okay, the overlapping of the wheels are mechanically good, but see again, what is the problem here? The teeth of the wheels are getting collided. So where is our code? Go to the code. This is wheel 2 dot rotate. Okay, so this is wheel 3 dot rotate. Give proper naming. Wheel 3 dot rotate. Sorry, underscore. Give underscore. Okay, wheel 3 underscore rotate. And wheel 3 rotate, what we should give, it should be the opposite rotation of wheel 2. So opposite, how can we give? Into -1. Okay, give edit. Now let us check. Let us check with this one, but this won't work because it is getting influenced by this one. Okay, but if I should rotate this, if I'm selecting and rotating this should also get rotated, but this is being controlled by this one. So this is the master controller. Okay, let us check. See, it is working fine. Okay, see, it is working fine. This is one what kind of way which we can use in mechanical rigging, right? So I just wanted you all to practice, okay, with multiple number of wheels, and I wanted you to practice with multiple number of wheels, like say for example, I'm going to duplicate this wheel and we're going to keep it here. So let us make a shape of an alphabet S. Okay, so S shaped alphabet, we'll make it, or what, some shape of thing we'll make it. Like I'm going to make it duplicate of this, I'm going to keep it here. Duplicate of this, I'm going to keep it here. Okay, or I'm going to keep it here. Duplicate this, and I'm going to keep it here. Duplicate this, I'm going to keep it here. Okay, this may be a chain structure within a machine or something like that. Okay, this is a kind of what practice exercise, so that you can come to know how or where to give clear inputs for the wheel rotations and all those things. The connectivity, it is not only the wheels, okay, you can give transform also. Okay, say for example, like how we did in set driven key, we in set driven key we can connect transform with scale, and any attribute can connect with any attribute. Okay, so similarly, say for example here I'm going to select the translate y. Okay, and I can copy the translate y here. Okay, I can translate wheel on dot translate y, can control the translation or rotation, even rotation also. Okay, so just to not to confuse and make it simple, I have used only rotation to rotation, rotate z to rotate z example. Okay, so this is going to help us in mechanical rigging. So I just wanted all of you to practice like this. Okay, so now one wheel rotation is controlling this 1, 2 and 3. So we have did written the coding in 2 and 3. So this 3 should control this 4, and the 4 should control this 5, 6, 7, 8. Okay, at least some 5 or 6 different connectivity you should try. Okay, only then it will be clear. Okay, your task is to practice the lattice deformer for the stretch and squash of the ball using the squash deformers, and trying this wheel connectivity and all those things. The next session we will start applying all these things in the mechanical rigging, right? Thank you.